Hello viewers, welcome to the part 5 of the step-by-step Oracle Data Guard series, and in this part we are going to talk about Data Guard protection modes. So viewers, in this series I am covering various topics on Oracle Data Guard like architecture, implementation, administration, management, monitoring, etc., which I am listing below. Each of the topic may need one or more tutorials to cover it completely. I assume you are already an Oracle DBA or familiar with at least the basics of Oracle database architecture. I will keep everything simple so there won't be any difficulty in understanding the concepts even if you are a beginner. Please note that whatever commands I am using in this tutorial, they are all available in a shared document in my Google Drive. You can access that using the link in the description of this video below. Moreover, I am using Oracle Enterprise Manager extensively in this whole series. If you want to learn more about OEM and become a master in OEM, starting from installation, monitoring, alerting, upgrade, patching, etc., please watch my 16-part YouTube series named Mastering OEM, for which I have given the link in the description of this video below. Before I start the demonstration, let's first get familiar with the test environment that I'm using. In this demo, the primary and the standby databases are with DB unique name testdz1 and testdz2 respectively, and they are created in Oracle Database version 19.3. For monitoring and management, I am using OEM version 13.5. All the database and OEM servers have the 64-bit Oracle Linux 7.9 installed. I am doing all these demonstrations in my virtual environment created using Oracle VirtualBox virtual machines. If you want to create your own virtual learning environment, please watch my tutorials using the link given in the description of this video below. So far in this series, we created a physical standby database using OEM 13c, discussed about the data guard architecture, configuration, switchover, failover, monitoring and alerting using OEM, etc. If you have not watched the previous parts in this series, I suggest you watch them first to get a better understanding on what we are going to discuss in the next. Now, let's start with the main topic of this tutorial, that is the data guard protection modes. So, what is a protection mode and what are the different types of protection modes in a data guard system? Protection modes define how you protect your data or the primary database from any disaster. Simply having a standby database does not mean your data or the primary database is 100% protected. To get protected from any data loss, you must deploy a proper protection mode. Data Guard offers us 3 protection modes for the primary database in the event of a disaster, which are maximum performance, maximum availability, and maximum protection. Now, let's discuss in detail what are all these protection modes and how they protect the primary database. We will start from the bottom. First, the maximum performance. This protection mode provides the highest level of data protection that is possible without affecting the performance of the primary database. If you deploy this protection mode, you will get best performance with your data guard setup, but there is always a chance that you will lose some data in the event of a disaster. I will explain this with an example shortly. Second, the maximum availability. This protection mode provides the highest level of data protection that is possible without compromising the availability of the primary database. If you deploy this protection mode, your primary database will be always available until a disaster happens, and DataGuard will try to give you 100% protection against any data loss under normal operation when your standby is available. But it will not guarantee that, and you may still end up losing some data if your standby is unavailable in between. Third, the maximum protection. This protection mode provides the maximum protection even against multiple failures, but it compromises availability and performance of the primary database. If you deploy this protection mode, DataGuard will guarantee 100% protection against any data loss as long as your standby is available, no matter what happens to the primary. That means, even if your primary database server is burned beyond any recovery, you will get back 100% of all your data from the standby database. Typically, maximum availability provides a higher level of protection than maximum performance, and maximum protection provides the highest level of protection. Now let's go a little deeper and understand each of these protection modes with their behavior and protection level. Each of these protection modes are actually governed by the log transport mode from primary and the log acknowledgement mode from the standby. The log transport mode along with the log acknowledgement mode settings actually determines how the changes will be committed on the primary. Log transport mode can take any of the two values called sync and async, and the acknowledgement mode can take any of the two values called affirm and no affirm. These values are actually set in the log archive -n parameter of the primary database. For example, in our primary database with the unique name testdg1, we have these values set in the log archive -2 parameter. There are many other attributes in this parameter like delay, optional, compression, max failure, etc. The details of each of these attributes are given in the description of this video below. Now, first let's take the maximum performance mode and understand why some data loss may occur. In this mode, where log transport is async and acknowledgement mode is no affirm, means that the commits in the primary don't wait for the standby's acknowledgement. If the standby server is down, unreachable due to, say, network failure, even then also the primary database will continue committing its changes as long as it can write those changes to the online redo logs of the primary. This mode gives the best performance in the primary because the primary doesn't have to wait for any acknowledgement signal from the standby to proceed to the commit operation. In slower networks, this mode fits well where performance of the primary database matters more than the data protection. But if a disaster happens to the primary, this mode results in losing some of your most recent changes which were not yet propagated to the standby. Next, let's take the maximum availability mode. In this mode, log transport must be sync, but acknowledgement mode can be affirm or no affirm. With sync and affirm, the changes will be committed in the primary only when it receives the acknowledgement signal from the standby that the redo data has been written to the disk. With sync and no affirm, also called as fast sync, the changes will be committed in the primary only when it receives the acknowledgement signal from the standby that the redo data has been received by the standby. In this mode, if the standby server is down or unreachable, say due to a network issue, primary will change its operation mode and continue committing its changes as it were in maximum performance mode to make sure primary is always available to the users. This mode often compromises the performance of the primary in slower networks as it needs to wait for the acknowledgement signal from the standby, but does not compromise the availability of the primary. When the standby is available or online again, it will change its operation mode to maximum availability again. So, under normal operations, this mode guarantees 100% protection against data loss if the standby is available, but does not guarantee the same if the standby was not available for some time. And finally, let's take the maximum protection mode. In this mode, log transport must be sync and the acknowledgement must be in affirm mode. So, as explained before, with this mode, the changes will be committed in the primary only when it receives the acknowledgement signal from the standby that redo data has been written to the disk. It often compromises the performance of the primary database as it needs to wait for the acknowledgement signals from the standby. But the bigger thing is, it also compromises the availability. Because in this mode, if the standby server is down or unreachable, the primary will shut itself down without committing the current transaction to make sure there is no data loss. And that's the reason Oracle suggests if you are using maximum protection mode, you should at least have 2 standbys. So in the event of one standby is not available, the primary will at least continue with the second standby instead of shutting itself down. So we have learned about the 3 different protection modes and now we will see them in action. I will mainly use OEM to make changes in the protection mode and settings, but I will also mention the equivalent DataGuard broker and SQL commands to achieve the same. Here's a recap before we proceed. So I have my 2 Linux servers named Linux 1, which is my primary server, and Linux 2, which is our standby server. And the primary server has the primary database with the name testdz, for which I have already set up the environment, and we will simply call the DataGuard manager command prompt. From here, I logged in as sys, and I'll use the command show configuration, and we see that the testdz1 is currently the primary database and testdz2 is the physical standby database, and our DataGuard broker configuration is working fine. Now let's go back to our OEM console. I will log in to my OEM system using sysman user, and then I will list out all our target databases. And as you can see, this testdz1, that is the primary database, and testdz2, that is the standby database, both are listed as target databases in my OEM system. I am in the home page of the primary database named testdz1, and from here I will go to the DataGuard administration page under the availability menu. So availability and then DataGuard administration. It will ask for the password for the sys user. So I am going to create a new named credential so that we don't have to supply the password every time we try to log in. Put the username as sys and the password, and the role will be sysdba, and we'll save it as nc testdz underscore sys, and we'll also set it as a preferred credential for the database instance, and this name credential will be with sysdba database credentials. Let's log in, and in the DataGuard administration page we can see that everything is working as expected, and we see that the protection mode is currently with maximum performance. This is the default protection mode which was assigned when we initially created our first standby database. Now if we want to change this protection mode to the next level, that is the maximum availability, all we need to do is to click on this maximum performance link, and from here select this maximum availability option. The equivalent commands in the SQL prompt and in the DZ broker are given in the description of this video below. If you don't have OEM, you can use those commands to change the protection mode. But before changing the protection mode, we will first check what is the current value of the log archive-2 parameter in the primary database. So I will first go to my primary server, and then I will connect to the primary database as sys, and we'll see the value of the log archive-2 parameter using show parameter log archive-2, and we see the parameter has currently async and no affirm set as the log transport and acknowledgement modes. This is the default settings for max performance mode of protection, which was set automatically when we created the standby database. If you want to stay in this max performance mode of protection, you should leave it this way. Else, DataGuard will give you a warning saying log transport mode is not consistent with the protection mode. But as we are going to switch the protection mode from max performance to max availability, so we can change it, and we will do that using OEM. This is an online activity and no DB bounce is required in the primary or in the standby database. So we'll go back to the OEM console, and there we'll select the maximum availability protection mode, and here it says that the maximum availability provides a high data protection, no primary database downtime if connectivity to the standby database is lost, but data may be diverse, and this requires the log transport mode to be set to sync if not already set. So as we have seen that the log transport mode is currently async, so this activity is automatically going to set it to sync. So let's click on the continue button, and it will ask for a confirmation. Click on the continue button, and then click on the yes. It will take a couple of seconds to apply the changes and show us the new configuration status and the processing completed, and it will take us to the original screen where it says that the protection mode has been successfully changed. And now we see the protection mode here is maximum availability, and it has a couple of warnings which should go away automatically within a few seconds. Let's refresh the page, and we can see that everything is all set now, and the protection mode is maximum availability and all are green. Now let's go back to our SQL prompt, and in the primary database, let's check the log archive -2 parameter settings, and now we see that the value has been changed to sync affirm. Earlier it was async no affirm. Let's go back to OEM console. Now if we want to change the protection mode to the next higher level, that is the maximum protection mode, then all we need to do is to again click on the maximum availability link here, and then we see we have now all the options available, whether we want to go to the maximum performance level or maximum protection level. All these three options are now available. We just need to select this maximum protection mode and then click on the continue button. But before doing that, let's see what it is saying. Maximum protection provides the highest level of data protection. No data will be lost. Possible primary database downtime if connectivity to the standby database is lost. This requires the sync redo transport mode to be set on at least one standby database. Now we have only one standby database, and we have already set the mode to sync, and also it is affirm. Although it is not said here, we must set the sync and affirm settings in the log transport mode or the log archive -2 parameter to change the protection mode to maximum protection. Now click on the continue button. Again, click on the continue button, and in the confirmation page, click yes. I have given the equivalent commands in the description of this video. Again, if you don't have OEM, you'll be able to use those commands. Now we are back to the OEM console in the DataGuard administration page, and we can see that the protection mode has been successfully changed, and we see that the value now here is maximum protection. Now let's do another test. We will temporarily shut down the standby database and see if the primary database automatically shuts itself down or not. Because as per the requirement of the maximum protection mode, it should shut down automatically if it is not able to access the standby database. To validate that, we will go to the primary server. I have connected to this server as the Oracle user, and I'm going to use the tail -f command to find out what is happening through the alert log of the test DG1, that is our primary database. Right now nothing is happening. Now I will go to the standby server, connect to the standby database as sysdba, this is our standby database. Let's check the database role and open mode. We see this is the physical standby, and currently it is open in read-only mode with apply option. So I will shut down the database, and in the first place it gives me the message saying that database is busy. It is because the protection mode is currently set as maximum protection in the primary, and in this situation it will try to make us aware of the fact that we should not shut down the standby database, because that is going to create an outage in the production database or the primary database. So in this case, we have to forcefully shut down the standby database using shutdown abort command, and we'll see what is happening in the other session. And in the alert log of the primary database, we can see that it is encountering the TNS error because it is not able to connect to the standby database. hundreds of lines of error messages about connection refused have been logged into the alert.log file. Now at this stage, if we try to do anything in the primary database, the database is going to shut down immediately. Now let's go back to our SQL Plus session as sys, and I will simply try to do a simple select statement. Select sysdate from dual, and then I will try to do a small change which is going to create some redo. Say create table t as select sysdate sd from dual. Now this is going to create a small table, and it's a DDL statement, so definitely it's going to generate some redo, and that will bring down our primary database because it's not going to allow us to do any change. Let's see what happens. Looks like it is stuck there. Let's go back to the other session that is showing us the alert log contents. And we see a couple of new lines introduced here with a warning: all standby database destinations have failed. Instance shutdown required to protect primary. And at the end, we can see that the instance has been terminated. Let's go back to our SQL session. We see that the expected error message is there, and it did not make the change to create our test table. So the primary has shut down itself, not to accept any more changes and to protect the data. Again, a word of precaution: if you are using maximum protection mode, you should at least have 2 standbys to avoid a service outage in your production database. So that's it for this episode. So viewers, please provide your feedback in the comments section of the video and hit the like button if you found it useful. That will mean a lot to me and help grow this channel.